Now we're going to look at something very special. So far, we've always had functions that when we look at the first derivative, we have slope or something like that. But we will run into cases where the function is what's called indeterminate in form. Which means this. If you have a rational expression at some value x, and you get 0 over 0 or infinity over infinity, then that's called indeterminate. Why? Because 0 over 0 is not a number. The question's always been raised, well, what is 0 divided by 0? Is it undefined or is it 1? Argument is, whenever you have the same number over itself, isn't that 1? But there's another rule that says you can't divide by 0. Same with infinity. Infinities, since these are the same infinities, is that 1 or is it infinity? That's why these are indeterminate. We can't do anything with those. But the beautiful thing is if this is true, if it is indeterminate in form, then you can try to factor both f of x and g of x to remove the common part that make them equal 0 over 0 or infinity over infinity. For example, if we have this function at x equals -3, so if I plug in -3 in there, and I work it out, -3 squared is 9. Positive times negative is negative. 5 times 3 is 15. Plus 6. -3 plus 3 is 0. 9 plus 6 is 15. 15 minus 15 is 0 over 0. Whenever you have that, that tells you that both of these equations have to have something in common that make it equal 0. So what you can do if it's simple enough, you can factor out these equations the best you can. So the top factors out into this, and we see that those cancel. Those are the parts at x equals -3. This is why it equals 0. So what I'm left with is that. So x plus 2 at x equals negative, or when equals -3 plus 2 equals -1. So that's my answer. Very much so. That's where we get to next. Yes. Yeah. So exactly. I'm glad you said that because now I can jump straight into it. So what it's saying here is if I have a function as f of x over g of x, as x goes to a, some number a, if we get that, if we get 0 over 0, that means a is in common with both of those functions. So if we get rid of that part, we come up with a solution. But what if we had an equation like this? As x gets closer to 0, what happens? So if we look at this, if the limit as x gets closer to 0, 3x minus sine x over x. So it's 3 times 0 minus sine of 0 over 0. We got 0 over 0, which is indeterminate. But we can't factor an x out of this thing because this is an angle, this is a variable. So we use L'Hopital's rule. L'Hopital's rule well, we can look at it. What does it really mean? It's the limit of a function is the difference quotient. So we use L'Hopital's rule. L'Hopital's rule says this. Actually, let me find the theorem. Suppose f of a equals g of a, and they both equal 0 at that point. So this is the first supposition. Also suppose that f and g are continuous and differentiable on some open interval AB. Shouldn't use AB, but I'm using A there. So I should use X1 and X2, where A is an element in that interval. It says that A is contained in, is an element of that function. Then the limit as x approaches a of f of x over g of x equals the same thing as the limit as x approaches a of the derivative of those functions. So this is the beauty of it. If we first have to test the function first, it has to be 0 over 0 or infinity over infinity before we use L'Hopital's rule. What this thing says, if it is indeterminate, then take a derivative of the top and the bottom separately, not a quotient rule, but individually, and then try it. If it still gives you 0 over 0, then take another derivative. Keep on taking the derivatives until one or both of the functions are no longer 0. Here's an example. The limit as x approaches 0 of 3x minus sine x over x. What's your first step? Yeah, first step, plug x into f of x and g of x. If we get 0 over 0 or infinity over infinity, then take the derivative of the top and the bottom and try it again. And repeat until one or both do not equal 0 or infinity. All right, so in this one, if we plug in 0, we get 3 times 0 minus sine of 0 over 0, which is 0 over 0. So we take the derivative. What's the derivative of 3x? 3. Minus, what's the derivative of sine? Cosine. What's the derivative of x? 1. Now we plug in 0. Cosine of 0 over 1. What is cosine of 0? 1. So there's your answer. Let's look at B. The limit as x approaches 0. Does it always have to approach 0? No, it's just whatever value makes them both top and bottom equal 0. So here we have our function. Limit as x approaches 0 of square root of 1 plus x minus 1 over x. So what's my first step? Yeah, plug in 0 for x. We got 0 over 0, so it's indeterminate. So now I take a derivative of top and bottom separately. How do I take we have this number here. How do we take a derivative of that? This is 1 plus x to the power 1/2. So the derivative of that is the chain rule. Subtract 1. Times the derivative of the inside, which is 1. So we get 1 over 2 square root of 1 plus x. So that's that first one. The derivative of 1 is 0. The derivative of x is 1. So we just plug it in here. So we have 1 over 2 square root of 1 plus 0. 1 over 2 square root of 1, which becomes 1/2. First step, does it equal 0? So we have 1 plus 0 minus 1, 0 over 2 over 0 squared. So square root of 1 is 1 minus 0 over 0. So it's 0 over 0. You have to first test that out, make sure it works. We just did this one, so we get 1 over 1 plus x. Derivative of 1 is 0. The derivative of x over 2 is 1 over 2. And the derivative of x squared is 2x. Plug in 0. 2, 1 plus 0 minus 0 minus 1/2 over 2 times 0. So it's 1 over 2 minus 0 minus 1/2 over 0. It's 0 over 0. So guess what? We got to do it again. So now our function is 2, 1 plus x minus 1/2. the derivative of 2x is 2 on the bottom. The derivative of 1/2 is 0. So we just have to take the derivative of this part. 1/2 square root of 1 plus x is equal to 1/2 1 plus x to the power 1/2, 1/2 1 plus x to the power negative 1/2. Now we take a derivative of this one. Take the power, bring it down, so it's negative 1/2. And subtract 1 makes it negative 3/2. Negative 1/4. One plus x 3/2. So that's the derivative of this equation. The second derivative. Plug in x. We have 4, 1 plus 0, 3/2, negative 1/2. 1 plus 0 is 1. 1 to anything is 1. This is a reciprocal function, so it's negative 1/4 over 2/1. Flip the bottom, so it's negative 1/8. You take the top fraction, leave it alone, and flip the bottom. So it's negative 1/4 times 1/2. Okay, so far so good? So this is the beauty of it, because now we really don't have to worry about quotient rule or product rules, because it's just the f of x and g of x, the derivative of those. The limit as x approaches 0 of x minus sine x, x cubed. So it's 0 minus sine of 0 over 0 cubed. 0 minus 0/0 is 0/0. That's my first step. So I take the first derivative of the top and the bottom. The derivative of x is minus derivative of sine, derivative of x cubed. Right. Plug in 0. So cosine of 0, 3 times 0 squared. Cosine of 0 is 1. So it's 0/0 again. So we take another derivative. The derivative of 1 is 0. The derivative of cosine is negative sine it. And then this 6x, which becomes positive sine x over 6x. Sine of 0, 6 times 0 is 0/0. So we take a derivative of this function. Derivative of sine is cosine. Derivative of 6x is 6. One over 6. All that for 1 over 6. Let's look at another one. So the limit as x approaches 0 of 1 minus cosine x over x plus x squared. So it's going to give us 0 over 0. Derivative of 1 is 0. Derivative of cosine is negative sine. Derivative of x is 1. Derivative of x squared is 2x. So it's positive sine over 1 plus 2x. So we have sine of 0, 1 plus 2 times 0. Sine of 0 is 0. 1 plus 0, 0 over 1. So the answer is 0. Okay, you have to be very careful how to do this. Fortunately, all the derivatives are very small. You have to be very careful. The limit, oh, this is one-sided limits. Because remember, we looked at everything that dealt inside the open interval. What about looking at endpoints? Whenever you look at endpoints, you're looking at one-sided limits. So we're looking at x approaches 0 from the right of sine x over x squared. So if I plug in 0, I get what? I get 0 over 0. So I take the derivative, limit as x approaches 0 from the right. The derivative of sine is cosine over 2x. So plug in 0. It actually means infinity. Because what does infinity, what does undefined really mean when I have, how many times does 0 go into 1? Infinite many times. So we just call it undefined just to make it easier for us. Let's look at the same equation. This time we're going to go from the left side. So we plug in 0 inside there, I get sine of 0 over 0. This is where it gets interesting. The derivative of sine is cosine over 2x. Cosine of 0 is 1. So how about this one? What does that equal? Negative infinity. Why is it negative infinity? Because all my x values that I'm plugging in here are negative values. So as I plug in negative values inside here, it goes to negative infinity. Okay, so far what we've done, we've looked at 0 over 0. We can look at infinity over infinity, or infinity times 0, or infinity minus infinity. Those are all indeterminate. Again, since they are indeterminate, they all follow the same rule, L'Hopital's rule. So here we have this one. The limit as x approaches pi over 2 of secant x 1 plus tangent x. First thing you have to do is test it. Secant of pi over 2 over 1 plus tangent pi over 2. What is secant? 1 over cosine. And tangent is sine over cosine. So sine pi over 2 over cosine pi over 2. Cosine pi over 2 is 0. Sine pi over 2 is 1. Cosine pi over 2 is 0. So it's 1 over 0 plus 1 plus, so it's basically the same thing. So we got infinity over infinity. So what do we do? L'Hopital's rule. Use L'Hopital's rule. Now you have to look at the derivatives. Since secant is 1 over cosine, the derivative of secant, we have to use the quotient rule. So it's 1 cosine. This is 0. This is negative sine. So the derivative of it is going to give us sine x over cosine squared x. This is the quotient rule. This is cosine times 0 minus 1 times that, which makes it positive. So this is sine x over cosine times 1 over cosine, which is tangent secant. So it's tangent secant. The derivative of 1 is 0. The derivative of tangent. Tangent is sine over cosine. So we have another quotient rule. Sine, cosine. The derivative of sine is cosine. Derivative of cosine is negative sine. So it's cosine squared x minus a negative makes it plus sine squared x over cosine squared x. Cosine squared plus sine squared is equal to 1, which is secant squared x. We can fix this algebraically. Tangent is sine over cosine. Secant is 1 over cosine over 1 over cosine squared. So I take the top fractions. I get sine over cosine times 1 over cosine and flip the bottom. Cosine squared over 1. So the two cosines cancel, and we're left with just sine x. Sine at pi over 2 is 1. Maybe I should ask y'all, how are your trig skills? On a scale from 1 to 10, where 10 you know it very well, 1 you're totally lost, where are you? Are you sure of 5? I mean, do you know? So what are the reciprocal rules? What are the Pythagorean rules for trigonometry?
No, no mind. One no.
Yeah, that's it. Be honest. I mean,
Okay.
there's no room for pride in here.
Okay.
So what I should do is, after we go through these, before we do the next section, we'll do the review of trigonometry. So to get everybody on the right page. All right, so let's do next example. Next one is the limit as x approaches infinity of ln x over 2 radical x. So the ln of infinity to radical infinity, we get infinity over infinity. So it's a prime candidate for L'Hopital's rule. So what's the derivative of ln x? One over x, very good. And on the bottom, the derivative of 2 radical x. So this the square root of x is x to the power 1/2. So the derivative is is 1/2 x to the power negative 1/2. So the 2's cancel. We're left with the limit of 1 over x. And this one is 1 over square root of x. We could look at both of these, which becomes the limit as x approaches infinity of 1 over x times the flip of the bottom. Since this is x to the power 1/2 and that's x to the power 1, we got 1 over square root of x. So this becomes 0. As x goes to infinity, this becomes, everybody follow me what's happening here. Because this is 1 over x, this is x to the power 1/2. I subtract 1/2. So x1 minus 1/2 leaves me with x to the power 1/2, which is 1 over square root of x. That's what this becomes. All right, last one. The limit of e to the power x over x squared as x approaches infinity. So we have e to the power infinity, infinity squared. We got infinity over infinity. So it's prime candidate for L'Hopital's rule. What's the derivative of e to the power x? E to the power x. Derivative of x squared, 2x. Plug in infinity. We still get infinity over infinity. So we do it again. The derivative of e to the power x is e to the power x. The derivative of 2x is 2. So we got infinity over 2, which is still infinity. And that's our answer. You keep on going until one or both of the terms are no longer infinity or 0.
So I have questions. So
Yep.
infinity over infinity, like 0 over 0.
Mm-hmm. Because they're not numbers. They're indeterminate. Yeah, because we have 4 categories. We have 0 over 0, infinity over infinity, infinity times 0, or infinity minus infinity. Those are the 4 conditions we're going to look at. Yeah, so since this one is infinity over 2, it's still infinity. All right, that's it for this one. No, we'll pick up from here next time. We're going to do example 5 from here on out. And then we'll finish up that section, and we're so close to finish this section. Oh well. But please start reviewing your algebra and your trig.